Hi, everybody. Welcome to this exciting panel. I'm very excited. It has a cool title. It's called The Latest and Greatest in Empirical Methods. And it's about machine learning and its application to strategy research. So this is amongst, for those familiar, amongst SMS, there's these panels on multiple topics, but there's always sort of like a Sunday panel on methods. And this is it. It's organized really by Olenka Kaspershik, who was kind enough to invite me to co-organize it with her. And her goal was, let's just showcase great ways to apply sort of these upcoming methods on data and machine learning to the questions about strategy. And so I was really excited to be invited to do it because I sort of got a chance to recommend sort of the people I admire a lot. And so we have great panelists here that are just going to tell us about their work, and I'm sort of really, really excited for what they're about to tell us. We have Sharon Belezon from Duke, Rob Seamans from NYU, Aija Leiponen from Cornell, and Choudhury from HBS. The format that we're going to do 12 minutes. We're going to have about 12 minutes, 4 presentations by them for one after the other. Feel free to post questions on the chat. I'm sure they'd love to answer them once they finish their talk. But really what we're hoping to do is leave 25 minutes or so at the end for a healthy and useful Q&A amongst all of us. And so if you write in the chat, that should not preclude you from asking your question in public, making sure it's part of the conversation. So without further ado, so I'm very excited to get started with Sharon.
Thank you. Thanks a lot. Jorge, let me just make sure, can you see my my slides, my screen?
Yeah, it looks perfect.
All right, great. So thank you, Jorge, and for the organizers and Olenka for inviting me for this really great conference, panel. So I have 10 minutes. I'll try to be kind of fast, and I'll try to kind of just gauge your interest in the kind of work we are trying to do. So I've been asked by Jorge to talk about machine learning applications to patent data, which we have been working on with for a long time. Jorge, just to make sure, if there's any problem in kind of hearing me or seeing anything, just kind of raise your hand or let me know. Okay.
You sound great. But
all right, excellent, great. So I'm going to talk about two applications. One is about how to use machine learning to essentially measure or identify, if you like, novel patents, novelty of inventions, of patented inventions. And the second application, which I'm going to show you, is the work that we are working on at the moment in trying to purge or classify patent citations to science into those that are meaningful and those that are not. And so, I'm not a computer scientist, so I'll try to motivate what I do by essentially showing you or kind of showing you the kind of questions that we are interested in and trying to explain why we think machine learning is relevant in our context. In other words, we're not just trying to apply machine learning for the sake of machine learning. We're trying to use it as another tool to answer questions which we believe to be important. Oops, sorry, my phone. 1 second. All right, so the first one is patent novelty. Why novelty is important? So just to motivate, we have been essentially looking at or seeing different trends in recent years. On the left-hand side, you can see that we, as a country, the US, have been investing a lot in R&D, in science, etc. On the other hand, on the right-hand side, we have seen a decline in potentially the returns to this investment as measured by productivity growth. This has kind of led to lots of discussion in the literature by different types of people with different views and perspectives. In our own work, we have emphasized one aspect of one potential reason for why we don't see significant substantial social returns to innovation. And we said maybe this is related somehow to the change in the composition of corporate R&D, potentially corporations moving away from doing more upstream research into more downstream research. And in this kind of paper,
I'm sorry,
this kind of,
Sharon,
Sharon,
can you go back to the previous slide, please? You kind of went over that kind of quickly. So the one on the left, what is that indicating to us again?
Okay, sorry. So this is like how much investments and how much scientific output we have in the economy. You can look at it in various ways. This is emphasizing more the upstream research side. But even when you look at R&D expenditures, companies are expanding, spending more and more money on research. Not only companies, I'm sorry, the whole country, the whole ecosystem. But the big this is from Gordon 2006, we see a decline in productivity. Now, clearly, in 10 minutes, I'm not able to tell you everything which is going on here. But this is just one kind of slide to say, let's kind of see why potentially this may happen. Different explanations, many different reasons. By the way, Jorge, I just realized I completely miscalculated the time I was hoping to spend on this. So no way I'm going to finish, just so you know now. But I'm going to kind of do it very, very quickly. So what we've in our research, we show that there is a composition in the allocation of R&D. Maybe we can just mute everybody. Yeah. We show that in our research that the D part of R&D, which is measured by patents, is increasing, and the R, which we measure with scientific articles, has been falling. What we are trying to do here, we're trying to see, let's see what is happening to the D. Is the D becoming more incremental or more novel, given that its importance has been on the rise? And here there are potentially two kind of different, another kind of strand in the literature. One says, look, it's called like the low-hanging fruit argument, or technological opportunities have been depleted. The reason we don't see lots of productivity is because companies are doing more incremental things, given that all the big ideas have been essentially being exploited. The flip side of that is, or not flip, but a different story, is essentially maybe related to rising the concentration of firms in the US, and maybe the incentives of corporations to engage in different types of R&D activities is related to how big they are. Again, different literature. But all these different kind of trends, macro trends that we see in the data, potentially can motivate the kind of questions that we try to ask. So what we do, we try to characterize the D side of R&D, hopefully with the hope of being able to say something intelligent about the debate in the literature, focusing on firm size, technological opportunities, and as well as changing the composition of R&D. I will not tell you how we do this because we don't have time, but I'm going to show you the main kind of building block of that, which is we want to try to look at the patterns of firms and say, have these patterns become more or less novel over time, and then do lots of stuff with it once we have this novelty at the invention level. Let me kind of skip this part, and let's kind of, for the sake of time, let me just kind of jump to how we do this. Actually, I will not even do that. I will just kind of tell you what the problem is. Actually, let me just also click on this and I'll go back. Look, people have been starting to essentially, in recent years, not lots, but a number of papers.
I agree.
Yeah, Jorge, just if you can mute. Yeah, so a bunch of papers have been coming out in different journals, from finance to economics to strategy, that essentially look at the text of inventions and trying to make the claim that if the text of inventions is more similar to what came before, then the inventions are more incremental. We have been doing this from 2008 in various, we haven't published the results, but we have been kind of working on this in various settings. And this is essentially what you see here is essentially what companies, what individuals have been working on, looking at the text and making the argument that if the text is more similar, it is likely to be if the text is more similar, the inventions are more similar as well. They're more incremental for that reason. The problem is that, and nobody in the literature was able to address this problem, but we have been working on this for a long time. The problem is that in the patent space, as well as in other spaces, there is little reason to expect that similarity in text is associated with the similarity in ideas. In other words, in the patent space, you can describe similar ideas in words that are very different from each other. And I'm going to essentially give you some reasons for why simply looking at the text is not sufficient. One obvious reason is that if I want to get my invention granted, I want to essentially fool the examiner in thinking that what I do is unique. I have an incentive as an inventor to describe my ideas in ways that are different deliberately from the ways that similar ideas have been described in the past. So even if and by the way, so this is something that we've looked at a lot. You cannot imagine how many ways people use to describe bicycles, for example, or containers of water, etc. How do you essentially infer similarity of text if the text that can be used to describe similar ideas is so different from each other? So this is one challenge. Other challenges may be related to different levels of maturity of fields. For example, if you look at economic papers, I'm sure economics is a more mature field than strategy. The text which is used to describe similar papers is going to be more standardized. In fields that are emerging, that are still new, that there is no clear scientific background, you may see way more ways to describe similar ideas. So the text itself is problematic, and the biases that emerge from these issues are likely to be systematic and really depend on the question that you are answering. Nobody in the literature has even started to think about those issues, to the best of my knowledge. We have been trying to do that, and I'm going to show you how. So the way we kind of said, we are going to let's use machine learning to try and use human knowledge. Let's kind of try and think about systematic repository of experts that actually read papers and decided whether they are similar or not based on whether there is an overlap in the text, but whether there is an overlap in the ideas. And we thought that one of the best ways to do that is looking at examiner, what is called non-rejection or non-final rejections. Non-final rejections is, think about it as a referee report that you get when you apply for a patent. And this is an example of how it looks like. You submit an application, and then an expert that knows the literature, not because you ran a search of how similar your text is to other text. His job or her job is actually to kind of read, understand the content, and see whether this content is new or not, regardless of how you describe it. So his job or her job is to know that if you invent a bicycle, it is a bicycle, even if you describe it in ways that are very different. Even if you don't use the word bicycle in the description of the invention. So what we do is we essentially look at all these rejections. When we started to do this was not automated, so it was really hard to do. So we kind of had to kind of get this data and manage it in ways that essentially were that we could use. And what this guy says is this application is rejected, or the specific claims are rejected because they're anticipated, they're too similar to this patent. The patent that kind of was granted was published before. There are two types of rejections. I won't get into it, but just kind of 102, 103. These are the relevant ones. You downloaded this, all this stuff, processed it, and then essentially what we managed to do using semantic algorithms. Here, the innovation was not really on the semantic space. This was something that is more traditional. The innovation was, how can we find a training set that would tell you what is the likelihood that two words that can be different from each other and are likely to be different from each other speak to the same underlying scientific concept. With that, we created this dictionary, which we call synonyms. And one example is, if we kind of look at the word DDR, then we get a bunch of synonyms with weights that tell us what is the likelihood that if we see DDR and the other word appearing together, what is the likelihood that they talk about the same document based on the training set, based on the model that we train, based on the exam. If we kind of randomly select an examiner, he would essentially associate these two words with documents that he or she would deem to be scientifically related, either via 102 or 103 rejections. 102 is novelty, and 103 is non-obviousness. Okay. Based on that, we essentially run all this text matching, but the most important thing is we also weight similarity of words. We also kind of take into account similarity of words that are different from each other based on the dictionary that we put together. And then we have a procedure that I'm happy to explain later on, an algorithm that allows us to say how similar an invention is to the inventions or to the patents that came before it. based on the text and also the potential relatedness of words to each other. This is an example of highly incremental pattern, and you can see the two patterns, the kind of the focal one on the left and the one that came before it on the right. The right one is the one that we identified to be the closest based on the text. And let me kind of, and this is kind of the most, novel invention, because you see that the one on the right is very different from the one on the left, and the one on the right is the closest that we find to the one on the left. With this, we do various things, and I'm going to, so Jorge, how much time do I have? Sorry, I
So
lost.
you're at 15 minutes now, so
15 minutes. I'm going to skip all this. I'm sorry, I apologize. Let me just tell you one last thing, which is really interesting, what we have been working on now. Pattern citations is really cool. People have been using it a lot, but there is this kind of really puzzle that we have been trying to address. Jorge, give me like really 30 seconds. We have, in our work, we have found that companies participate in research less and less over time. They do less research. At the same time, corporate invention relies more on science. They cite more pattern citations. They cite more NPLs, non-patent literature. And many people believe that this is inconsistent, because how can companies create inventions that are more scientific if they don't have the absorptive capacity to do the science themselves? So we argue maybe there is some noise essentially in those citations. Maybe there are two types of citations to science. One type are citations that are meaningful. These are the really kind of citations that we can learn and use in our research as indicators of scientificness, essentially basing an invention in scientific principles, whereas the other citations are driven from a different distribution that have nothing to do with any observables, any kind of meaningful theoretical relationships with variables of interest. And these are simply there because over time it became easier to search, et cetera, et cetera. So what we do, we use an FMM, and here is, I think it's really cool, allowing us to estimate the relationship between NPL citations and outcome variables, and essentially split the sample, identify two types of distributions, one where there is a meaningful relationship and one where essentially there is noise. And you can see this is illustrated here. And what we do for every pattern, we're able to essentially estimate the probability that it belongs to the meaningful distribution versus belongs to the noisy distribution. And we do this for across to a long set of relationships, theoretical relationships. So I know that you are getting upset, Jorge. Last thing I would show is when you actually correct this, and the correction essentially is trying to associate or trying to find the probability that the citation a pattern makes to science is theoretically or is related to outcomes that we can understand or that we can essentially support with theory. Once you take this information into account, then you see something quite striking. You see a decline in NPL in the reliance of invention on science, like in the past decade. Rather than essentially flattening it out. So this is still a work in progress, but hopefully we just summarize this kind of 15 or 16 or 17 minutes, I'm sorry for the delay, that I spent with you, tries to essentially illustrate how we can use machine learning and advanced techniques, I think, to answer questions and puzzles in the economic and business literature. So Jorge, I'm going to stop here. And again, my apologies for not timing this better.
thanks, Sharon. That was actually super interesting. I really like the fact that a lot of the progress was both, as you said, using new methods, but also finding new data sets. And that's something I found in my work. Data science often is a lot more data than kind of like the science part and just finding that. So the next one we have is Raj.
Thank you. I think Sharon needs to stop sharing.
Okay.
Yep. Can you guys see my slides? So thank you, Jorge and Olenka, for this organizing this session, for inviting me. I'm going to follow the instructions very to the T. Jorge wanted me to review one prior paper. I'm going to review that from a purely methods point of view. So my name is Raj Choudhury. I'm at the Harvard Business School. And this paper that Jorge wanted me to talk about is joint work with 3 great co-authors. It's published in SMJ. So Dan Wong, Natalie Carlson, who's at Wharton now, and Tarun Khanna. And what we're doing in this paper is we're trying to use different machine learning methods to try to study CEO communication styles. Now, why? So once again, I'll just very quickly motivate the paper. This is, but spend most of my time on the methods. So CEO communication has been studied, or more broadly, the role of communication in the CEO's life has been studied quite extensively. So my colleague Rafaela Sadun has a recent paper which makes the point that it's a very important part of the CEO's job to communicate with internal and external stakeholders. A few years back, Connie had a wonderful paper with Margie Peterov saying that communication is not only about verbal communication, but we communicate a lot through non-verbal cues, facial expressions, for instance. And now, as Jorge very correctly pointed out, we have the ability to study new data sets, including videos and pictures and whatnot. And so the question that motivated, this is a purely methods paper. The question that motivated our study was, if we synthesize multidimensional data, which includes text and video, do we get some new insights on communication styles? So this is the data set. It's a very interesting data set that's publicly available to use. It's an oral history data set that HBS has created with lots of fascinating interviews with emerging market CEOs. I believe they have close to 200 interviews now. And this is across Africa and Latin America and Asia. And these interviews are quite unstructured, but with really, really senior either entrepreneurs or CEOs in these really important companies. So we took all that material and then we used 3 methods, just to cut to the methods section straight. So first we used LDA, which I now know many of us have used. And I think there's also a wonderful Academy of Management Annals paper by Kay Van, which talks about this method. So LDA, essentially, just in 30 seconds for folks who have not seen this, it is a bag of words method, which is trying to reconstruct what words constitute a topic and what topics constitute a document. And it uses a method called Gibbs sampling to infer that sort of probabilistic identification. So we used LDA to generate what topics we would see in these CEO interview transcripts. And one question that I'll point out is that in using this method, it's very important to now focus on what is the optimal number of topics. So when we did this method, we had to pre-specify that, but now there are ready-made off-the-shelf tools which optimize for algorithms and tell you what is the right number of topics you can identify for error minimization. So LDA was the first method we used. Then we used sentiment analysis, which is pretty standard as well. So we use this NRC emotion lexicon to sort of say, are the words being expressed by the CEOs more positive or negative or neutral? I think the real innovation came when we took the visual frames of the interviews. So we essentially took the 1.5-hour interviews on average and split it into like all their frames. And we use this facial recognition neural network algorithm to say, what are the expressions? This is a supervised machine learning algorithm. Are they expressing anger or contempt or disgust or fear or neutral or surprise? So there are some pre-specified emotions on each frame, and it's trying to generate a probabilistic score for each of these emotions. So that's what we have. We have the topics from the text, we have the emotion from the text, or the sentiment from the text, and we have these facial expressions. And then we are running a pure factor analysis. So what we finally ended up using was the sentiment of the text, the facial expressions, and something called the topic entropy, like how concentrated were the topics or distributed were the topics across each interview. And then, these correlations, I'm not really, the reviewers kept saying, okay, show us some correlations. So we put in some correlations. Once we had these identified styles, we had 5 styles communication styles that showed up based on the factor analysis. We call them, you can call them anything. We call them expressive. So expressive was very happy faces with lots of positive things they said, for instance, and you can infer the other. So we had 5 communication styles, and then what we did as almost a proof of concept said, okay, how do these styles correlate with some strategic outcome? And we chose completed acquisitions, and there were some statistically significant correlations. We also used a lasso model to find which topic was most correlated with acquisitions. But I guess the point is, I think that the generalizable point is, I guess this paper shows that now we can use these kinds of data that are available, and you can imagine all these other sources of video data on YouTube, on news channels, on whatnot, that can be used. And it's collapsing the multi-dimensional data into some meaningful sort of categories. And that's the point that this paper is trying to exemplify. So Jorge gave me permission to show like one more paper. So I added 2 slides in the last 5 minutes. So this is another methods paper, a purely methods paper I've written with a doctoral student, Ryan Allen, and a postdoc, Mike Endres. And this is a paper which talks about how we can use supervised machine learning methods to identify patterns in the data that might go unnoticed. So let me show you, so we used 4 supervised machine learning algorithms. We used a logit with lasso, we used decision tree, random forest, and neural network. And what this graphic is showing is for a sample of employees at a tech firm, how many months they have spent in the company, that's the x-axis, and what is their performance in training on the y-axis. And then the color is telling what is their chance of attrition. So yellow is very high chance of attrition. So I guess, the pattern that emerged in this data was that unlike the logistic regression, the neural network is showing that in the early months of the tenure, if training performance is very low, then you are more likely to leave. And this was a very nuanced, non-linear effect that, if your training performance was low, you leave early on. Beyond that, actually, you stay a longer time. But the average effects in the logistic regression was not showing that. And there are other nuanced things we discovered in the paper. So the point we made is that supervised machine learning, one of the applications might be to identify patterns, then we can abductively explain or more causally go and test in a different data set. So it might become a pattern recognition tool. And as part of that exercise, I'll just show 2 last slides and stop. What we did, as we learned this material working with computer scientists, we said, why don't we codify it for other colleagues? So there are 2 useful tables in this paper, I think. One is just giving a summary of the methods we've used in the paper, and then giving some relative strengths and weaknesses, what kinds of applications are more suitable for that method. And by the way, we also made all the code and all the data for this paper public. So feel free to use the data, the code, and then you can modify it for your own applications. And then finally, I think this is a really important point, which our editor encouraged us to add, and I'm very thankful for that when you're running machine learning methods, it's not that you're not taking decisions. The human is taking lots of decisions. And we are relatively early, at least in strategy, in using these methods. So it's important to sort of come together as a community to say, what are the decisions that need to be taken? And as reviewers, as editors, we need to ask for clarity and transparency on those decisions. So let me give you a few examples. So when you are setting hyperparameters, authors should state which hyperparameters are being used and at what levels. When you are training the data, you need to say, what is your cross-validation method? Are you using tenfolds? Are you using something else? When you are reporting performance of the model, you need to say, what is the loss function that you're using? And if it's a different loss function is giving you a different set of results, you need to be transparent about that. And I can go on and on and on. So there's a table in the paper which says what are the human decisions at each step of running a supervised machine learning algorithm. And I think it's not only helpful for authors, But if you get a paper on machine learning as a reviewer, I think this table can be helpful to say, hey, can you report this statistic? Because in our traditional regression, we know what to report, but in machine learning, I think this is a helpful guide to both report and then demand the authors report something. So I'll stop there, Jorge. I hope this was helpful. Stop share.
Thanks, Raj. That was really amazing. It's really exciting to see a table of what should be best practices for our field in these, what's like the right etiquette for our field in this area. And I agree that is going to be very, very useful reviewing papers and writing papers. The next one we had in the order is Aija.
Sorry. Hi, everyone. Took me a while to find the mute button, which jumped on a different screen. So this is great. Thank you, Raj and Sharon, for those really, really interesting presentations. And thank you, Jorge and Olenka, for inviting me to be part of this panel. I'm definitely kind of want to say upfront that this is what I'm going to present is not the latest and greatest in machine learning. I'm really going to be more on the application side and kind of just talk about a couple of projects in which we have tried to apply these methods and kind of taking really small steps myself in trying to understand what we can gain out of these methods and where they help us open up the data, kind of new data troves, because that's how I really see this opportunity from my own perspective. I'm a very applied researcher. I look at the world and try to explain it, and I kind of adopt methods when I see something useful coming on the horizon. So I'm really more excited about the natural language processing aspect of machine learning techniques than the machine learning per se. So as social scientists, I think we're interested in a lot of social behaviors or economic business behaviors. And a lot of those things are documented in text that has previously been quite tedious to analyze. And now we have really rapidly expanding methods and tools to efficiently create new kinds of databases about behavior or intent or strategies or whatnot. And so Jorge and Olenka asked me to talk a little bit about annual reports, 10K types of firm disclosures that we have used in with machine learning methods to try to infer strategies from. So let's see, can I switch? Okay, so I was going to talk about two projects, one related to data privacy strategies and another one related to innovation disclosure, which is my students' project, and then conclude what have we learned? What were we not able to do previously? On the first slide, I wanted to mention that this has been joint work with Yolanda Zhu, Farzan Burumand, and Gunita Vasudeva Singh, who is actually also in this session. So Gunita might chime in on some of these things. They're my partners in crime. Okay, so what are annual reports? Why did we gravitate towards this source of information? Well, there's a lot of real information in annual reports, and so it's kind of a legally stipulated framework for disclosing materially important information about firm investments, activities, and performance. And so they are audited. They must disclose business risks that are really important and legally binding. There are civil liabilities. And so really the annual reports tend to be truthful, but there's nuance to it. And so we have to take what's there with a grain of salt, but at the same time, firms that intentionally lie in their annual reports are doing very, very risky, engaging in very risky activities, and they're individually risky. So that's why there's maybe it's already a large literature, but definitely growing literature analyzing 10K texts, and starting from probably before Holberg and Phillips, but they definitely have been very influential in kind of showing how to use these techniques with annual reports. And they've created a powerful way to redefine product markets. But there's a bunch of, in my area of interest, data strategies. There's a couple of papers using 10K texts, Wang et al. And Saunders et al. And most recent paper we saw in SMJ by Choi et al. So there's a lot going on. A lot of people are starting to use annual report texts. And our take on it is that it reflects the manager's attention. So not everything is in the annual reports. There's some strategic hiding or kind of vagueness around how things are expressed there, but whatever gets in the annual report reflects the firm's top manager's attention on their kind of strategic agenda. And so things that are there probably are related to some strategic action, but there might be other things that are just kind of on the horizon and they're not necessarily doing anything about those issues yet, but they're just observed as potential risks or opportunities. And so that's why we're thinking that managerial attention to things like data privacy and security breaches or market opportunities for new products might contain some useful information about future activities, strategic actions on the part of the firm. So looking at those data privacy risks here, the issue was that it was really difficult to find data about what firms are doing with their data, commodities, goods, assets, and so on. And so we had the idea of looking into annual reports. Maybe there's something there. Let's see if firms talk about data in their annual reports, and decided to focus more on the privacy side of data management and data assets to kind of build onto an ongoing stream of literature. So we used also topic modeling method to interpret the data, or interpret the text and form data variables out of that. And so Raj already started talking about that, the latent Dirichlet method. Here's basically the overall stream of activities that needed to happen in order to form variables related to data privacy. We took item 1 and item 1A from the annual report, which are the business description and the risk factors. We took all the paragraphs in the text that contained the word data, cleaned it, created a corpus of documents. So each paragraph is a document, trained the model using LDA. And then there was some adjustment of the number of topics that Raj also talked about. Some human judgment went into that. We measured topic coherence scores and kind of adjusted based on that. And then in the final kind of step, we end up with an average year level, firm year level average of topics in annual reports for each of those firms. So these are the topics that we focused on, or that we found. We selected 7 topics, 0 topic plus 6. And the data privacy topic is this one that contains words like data law, regulation, privacy protection, state requirement, information, and security. So then each firm will have a kind of a profile of topics for each of their annual reports. Here is Facebook's data strategy topics. And as you can see, after 2015, when Cambridge Analytica started happening, their focus on data privacy has been increasing. Here's some contrast to a United Health Services or health company where privacy concerns or privacy topics have actually been somewhat declining, but they are concerned about data systems failure topics in their annual reports more recently. So we found that there's some sense, some intuition from looking at these at the firm level. So then we just ran analysis, first explaining the attention to data privacy. So those text-based variables related to data privacy. And we found that GDPR and industry breaches, data breaches within the focal industry explain significantly the increased attention to data privacy in their annual report. And then we used the data privacy variable to explain performance with the kind of idea to find out whether data privacy is kind of a valued good in the marketplace, or if it's just a cost item. And it turns out that primarily it's negatively related to performance. So firms will only provide privacy goods if they're forced to, basically, is what we're finding out. How much time do I have? I don't see my clock, unfortunately.
You have 2-3 more minutes.
Okay.
Okay.
Thank you. I think you're being generous.
Yeah.
Okay. The other project is my student Yolanda Zhu's project, and I'll be really brief on this because it's not my own project, but I'm watching this very closely, and she's working. She's also using annual reports. So now the initial kind of idea is that maybe we can use annual report text to really learn about additional things about innovation that's not already in R&D data, in patent data, and I don't know what other data you might use for measure innovation. And so she's using she's sort of starting from the observation that year over year, when you read annual reports, they tend to be very similar for the same firm. So basically they add a little bit here and there to enhance or take out something from the annual report. So the business description and a lot of the report, apart from the numbers, tend to be very similar year after year. So when they change something in the report, that should be interesting. Why did they change it? Did something good happen or did something bad happen? And so Yolanda is looking at the innovation-related text. So she has a set of words that are related to innovation, such as technology, R&D, patents, and a few other things. And then she looks at the sentences around that word and how those evolve over time. Using cosine similarity scores in the kind of initial analysis, she finds that firms that tend to have high similarity of innovation-related text over time and have are greater than average R&D investors tend to have a positive correlation between similarity and performance in terms of Tobin's Q. And firms that don't invest a lot in R&D tend to have a negative correlation between similarity and performance. So the market wants low R&D performers to do more changes. They're too stagnant. And the market wants high performers to not change much. So that's a kind of an initial result. But I think more interestingly, from a broader methods perspective, the cosine similarity scores explain significantly for different overall and for different types of innovators beyond R&D, patents, and patent quality. And an interesting kind of type of firm where this score still explains quite a bit is non-patenting firms, where R&D doesn't really matter, patents don't matter. We don't really have a good understanding of do they do any kind of innovation at all. The cosine similarity score still explains something. And so the idea is that every firm that's publicly traded has to release an annual report. They might not be really doing meaningful amounts of high-tech R&D or applying for patents, but we might still from the text get some information about their innovation engagement using these text-based analyses. So I'm just going to jump to, did these methods add value? Well, we were able to generate data about issues that are important. We see them as important in the economy, but we haven't had really good ways of quantifying data strategies or innovation that's not R&D and patent based. We explained variation beyond word counts, but those were often highly aligned with our measures. So word counts are not that bad, but we want to go beyond that. Need to remember that disclosure is strategic. So what firms put in the annual report is very, very thoroughly thought out. And we have to kind of think about the mindset that generates the annual report. And I already mentioned that they tend to be repetitive. And so changes can be quite interesting and informative. Thank you. I have no idea how much time I spent, but thanks for your attention.
That was amazing. I thought the first paper was really inspiring because it got to the measurement stuff, which is something that a lot of machine learning work does, but then was able to find the shock that impacted that measurement and so use it for causal inference of data strategies. And I was really inspired by that. I've always found it very tricky to do both things at the same time. Rob.
Hi, I am just quickly sticking something into the chat here. And now let me pull up my presentation. You guys can see this okay? Yep, okay, yeah, great.
Looks great.
Great, so I'm gonna present a project that is now a paper that's been published called Occupational, Industry, and Geographic Exposure to Artificial Intelligence, a Novel Dataset and Its Potential Uses. And so for those of you that are interested, the link to the paper is in the chat, as well as a link to the data and the sort of methods that we use in this paper. So this is joint work with Ed Felton. He's a computer scientist at Princeton, and Manav Raj, who's a PhD student here at NYU. Just a quick note, Manav is on the job market this year. He's an incredibly promising student. And so if you're hiring, please take a close look at him. Okay, so there are a bunch of ways that I could motivate what we're doing here. Whoops. You guys can see this okay? Sorry, I just clicked something on my, great. So there are a bunch of ways I could motivate this. I'm gonna motivate, I sort of, in my mind, I sort of went through them all this morning, listening to everybody else. And I think in the interest of time, I'm gonna sort of jump to this as a way to motivate it. So Journal of Organization Design, some of you might know this journal, it's a newer journal. One of the great services that they do is they have these things called research primers, and they ask scholars to sort of write a quick primer on a certain area. So for example, there's one on M&A, there's one on corporate divestitures, there's one on corporate strategy. There are a bunch of these. They reached out to me and Manav Raj to write one of these a couple of years ago on artificial intelligence and robotics. Please take a look at it if you feel so inclined. One of the things that we do in the paper is we list out a bunch of questions that we think are important questions for strategy and organization scholars to answer. And I'm highlighting some of them here. There are others, but I'm highlighting some of them here. One of the questions in particular that Manav and I have been interested in is the one that I've highlighted. Under what organizational conditions does AI or robots substitute or complement for labor? In other work, I've started to dig into this when it comes to robots. Data on robots, it turns out, is more readily, still hard to come by, but more readily available. Back when we wrote this, we had a really hard time finding data sets that told us something about which organizations or which occupations are seeing adoption of AI or exposure to AI. And so we set out to create a data set that does that. And so that's this paper that I'm going to be describing to you. A few steps here, and I'm going to, in the interest of time, I'm going to sort of go quickly through parts of this, and I'll dwell a little bit more on other parts of it. Here's the roadmap for the next 8.5 minutes. Step one is to identify what we're going to call fundamental applications of AI. So I'll tell you how we do that. And then what we're going to do is I'll tell you how we map these applications of AI to occupational abilities. I'll probably spend most of my time on that. That's sort of step two. Step three is calculating occupation and industry level scores. If you're interested in that, I'm going to sort of skip over that. And if you're interested, you can take a look at the paper. And then I'll dwell a little bit on this validation of methodology. I think that this is an important piece. I'm not going to go into a ton of detail just in the interest of time. The paper does a whole lot of validation, and there's, I believe, also an online appendix that does a ton of validation. But I do want to, and actually maybe I'll sort of pause on it right now, because I think this is a thread that goes through all, the prior three presentations and my presentation. When we're thinking about new measures or new data sets, validation of the new measure, the new methodology, the new data set is sort of critically important, right? And it's not totally clear how one goes about validating it, right? You're coming up with a new measure, so that measure didn't already exist, right? Otherwise you'd use what already exists. So how do you validate this new thing that you came up with, right? There's not one single thing that you're sort of comparing it to. And so you're going to compare it to sort of, if you will, like a smorgasbord of other things that are out there, and just sort of try to validate what it is that you're doing. But I think that, especially for this session, Jorge, I think that this is sort of an important topic, this issue of validation. And so maybe it's something that we'll talk about in more detail in Q&A. Okay, so again, the first step is to identify fundamental applications of AI. So what we do is we take some information from this organization called Electronic Frontier Foundation. That are really well-regarded entity. And one of the things that they do is they list out progress in AI in different applications of AI. Okay, and so you can see some of them here. So for example, abstract strategy games, real-time video games, image recognition, etc. You can see the list of 10 that we end up using. There are many other applications that EFF lists. We sort of focus on these 10 because they are the 10 that sort of have the most data about them. As a side note, in the paper, we spend a lot of time also showing that what it is I'm about to show you is robust to other definitions of, if you will, applications of AI. Okay, so we have these 10 different applications of AI. And then what we're going to want to do is map these applications, or I guess I'll call them categories, to occupational abilities. So how do we do that? The Bureau of Labor and Statistics has something called Onet. And what Onet does is this is for the US, but other countries have something similar. Onet sort of breaks up all occupations in the US into 800, roughly occupations: CEO, orthodontist, telemarketer, someone who, surgeon, meat packer, right? So 800 occupations. And then for each of these occupations, it describes this occupation as a bundle of abilities. Okay, so 52 different abilities. I'm going to show you what that data looks like here. So this is for a chief executive. I don't have all 52 written here. Just I sort of cut it off at whatever this is, probably about 25 or so, right? But you could imagine that this list goes further. These 52 abilities are the same abilities, if you will, across all occupations. But each occupation is described as a weighted combination of these abilities. Okay, so here's this data value. It goes from 0 to 5. So let me just give you a sense of this. So oral expression for CEOs. This, by the way, is a link to the two prior presentations. Is very important, right? A possible weighting, maximal possible weighting of 5, and it gets a 5. Okay. In contrast, for a chief executive, for arm hand steadiness and manual dexterity, it's a 0. Okay. Now, for example, I've looked at orthodontist. For orthodontist, as you might imagine, arm hand steadiness and manual dexterity scores very, very high. It turns out also oral expression is pretty important for an orthodontist, but not quite as important as it is for a chief executive. Okay. Okay, so we have these 52 abilities, and again, keep in mind we have these 10 categories. And so what we do is we create a matrix. So along the top of the matrix, if you want to think about it this way, right? So along the top are these categories, right? The applications of AI, and the rows are the abilities. Okay. Now, what we're going to do, right? We want to somehow link AI to occupations, and so the way that we're going to do it is through this matrix. And so what you can imagine doing is for each of the cells in the matrix, put a 0 or a 1. A 0 if you don't think there's a link between, say, abstract strategy games and oral comprehension, or a 1 if you think that there is. Okay, so it's this big matrix. We started off filling this out ourselves, the 3 of us co-authors. We noticed something interesting, which is that there was a pretty high degree of correlation amongst the 3 of us. We then turned to doctoral students at Princeton and NYU in computer science and asked them to do the same. Again, we noticed that there was a pretty high correlation across them. And so with that as our, if you will, justification or our pilot, we then did this on MTurk with thousands of MTurkers. I'm happy to talk about how that went and how we motivated them appropriately and the sort of attention checks that we did and everything, but we sort of did everything we were supposed to. And we then end up with this big matrix. The matrix, by the way, is in that GitHub link if you're interested in seeing that. Sorry, and so now conceptually, you can imagine that what we're doing is we've got these AI applications. We have these abilities, they're linked via this matrix. And then for each of the occupations, we know how important they are. For each occupation, we know how important various abilities are. And so we can now go from these AI applications through the abilities and the weighting that Onet gives us to each of the occupations. Okay, and we end up with a weighted score for each occupation. That's this step 3 that, again, I refer you to the paper if you want to see more on that. I'm just going to skip over this. We then, as I said, spend a lot of time validating what we're doing. And so here are some of the steps that are listed. I'm just going to show you one of them, which is the correlation between our scores. Okay, so now for each occupation, we have what we are calling our AIOE score. Okay, so we can go from that and check the correlation between that and data from Burning Glass. Burning Glass, by the way, is a great data set. I'm sort of assuming many of you have heard of it. If you haven't, what they've done is they've scraped all the job listings in the US or perhaps around the world from 2007 to present. They scrape information including, salary and skills needed and things like that. One of the things that they have scraped is whether an AI skill is needed for that specific job. And so we've at the occupation level then create a share. What we do it a few different ways, but imagine it this way: a share of the jobs that are posted for that occupation that require AI skills. Okay, and so that's the y-axis, and the x-axis is our score. And it's noisy, right? But it turns out that it's actually a fairly strong correlation. I'm showing you the raw data here, and we do a bunch of stuff with regression tables and things like that. What this is showing is that if you score higher on our measure, you are more likely to have your occupation be one that requires some sort of AI skill. Okay, so that's one of the ways that we validate what we're doing. We think that there are a whole lot of applications of our score that we've now come up with. I just want to highlight sort of 3 things here. You can go from the occupation level to the industry level. So we also have these AI industry exposure scores. You can go to the geography level. So we've done this at the county level, but you could do it at other levels of geography. Okay, and I'll show you this in just a moment. You can also go to the organization level, so long as for the organization, you have some information about the occupations that are within the organization. And so we cite a few papers in our paper that do that, and that we believe are, sort of provide a roadmap for other folks that want to look at what's happening within an organization in terms of AI exposure. Here, just to give you sort of a visual, this gives you a sense of what this AIGE score looks like across the US. Perhaps not surprising, there's sort of places like Boston, New York, Bay Area, sort of Seattle and Portland that score pretty high, right? So there's sort of a high degree of this AI exposure. What's interesting to us is that there are a whole bunch of areas that you might not expect that, according to our data, show a high exposure to AI, right? So I think this is sort of like northern counties in Maine and sort of upstate New York that are bordering Canada. I'm happy to talk more about that, but I just wanted to give you a visual of what this part of the data looks like. Again, all the data is available on GitHub, and the paper is available via SMJ. It's an open access paper. So that's it for me. Thanks a lot. Let me stop sharing.
That was really, really, really cool. I learned a lot, Rob, in terms of how you guys approach it. But also, I think I was impressed at how, there's a lot more exposure in places that are growing more economically. And so I'm suspecting that maybe hints at more complementarities than substitution between AI and work.
Sorry, Jorge, can I just quickly, so yes, I mean, that's from our point of view, that's sort of one of the interesting things that are coming out of now working with the data that we've created. Is it turns out that it looks like there's a whole lot of complementarities between exposure to AI and things like wages and employment and things like that.
All right, okay, no, that's really interesting. Let me piggyback on your presentation with the first question. I don't see any hands raised in the participants, so let me then piggyback with your point about validation. And just, I mean, we saw 4 presentations. basically doing in the four of them, it was AI. There was a lot of machine learning that got to new measures of things that would be important, and then how could one apply those measures to understand strategy. And so maybe open up more broadly. But then obviously the question is, you have all these new measures, as Rob said, but you need to validate them. So what are best practices that our panelists think, or ideas about how do you think about these validation? What would be, if Raj were writing version 2.0 of his paper, what would be in the kind of things a reviewer should expect of validating a new measure, things like that. So, I mean, feel free to speak, anybody.
I'll just, since I'm already unmuted, I'll just quickly jump in. One thing that struck me both about Aija's paper and Sharon's paper is how well they know the context that they're studying. Raj, not that you don't, but this is just very specific to Aija and Sharon's paper. If you notice, Aija was talking about annual reports and the fact that stuff gets repeated every year and there's sort of a strategic element to it. That feels like really important context that one wants to keep in mind when thinking about how to validate what it is that they're doing. Same in Sharon's context, right? He was talking about how patents, how the inventors have these very strategic incentives, right, to sort of not look similar to other people, even though they might be very similar. And so it feels like an important piece to figuring out how to validate something is knowing the context that you're studying really well.
Jorge, I can add to that. So I think as both my talk and Aija's talk mentioned, if you're using topic modeling, I think it's critical to be transparent about the number of topics. And there's a pre-packaged module now, LDA tuning, that you can use. And so as a reviewer, I would expect a graph of the LDA tuning procedure to explicitly show how you chose the number of topics. If you're using supervised machine learning algorithms, there are many choices you're making. Which algorithm are you using? Are you using decision trees? Are you using neural nets? What are the hyperparameters you're using? So as an example, in a decision tree, where are you cutting off the tree? How are you doing regularization? How are you doing cross-validation? So I think all of that needs to be transparently reported in the paper, because as we all know, like these fine tweaks to the model can make the results very, very different. And as reviewers, we'll also have to develop maturity in asking these questions.
Shall we have website to support the papers? Maybe that's the direction. What I mean by that is that given that you have to move all these hyperparameters, that might make sense, to show how by moving all these hyperparameters, you can have different results. You think that's feasible, because the paper is still 40 pages. No?
And that's a great point, Marco. So I'll offer my quick perspective, and then other panelists might join. So I think we need to be transparent, and I know some journals are asking for the data and the code now, so maybe that's something strategy editors can consider. But at least at a minimum, showing robustness checks with other algorithms, other hyperparameters is a first order. But I'll stop.
I can actually, if you want me to jump in.
Oh yes, please, Sharon.
Can I ask you a question, Jorge? What can you kind of tell us, why did you choose to have a panel on this topic?
Why did we choose to have a panel on this topic? Well, we think, Lenka and I thought this is a methods topic, and there's both an interest from the strategy community in terms of using machine learning, but I think bigger than that, there's a sense, at least for me, that strategy has always kind of limped a little bit on this leg, which is like sort of conceptually it sounds perfect, but it's hard to measure because it's about heterogeneity, not average effects. And so there is hope in my mind that it's actually going to change a lot in the very short term. It's going to be sort of much more kind of robust, statistically, thanks to the ongoing work of machine learning.
Thanks. So Jorge, maybe I can just jump in and build on what you said. So I think So this is just my perspective and how I see things and how I choose my market and how I choose to compete in this space. I think there are two types of kind of research agendas around AI and machine learning. The one is along the lines of Rob and others that studying AI and machine learning as a phenomena, as an economic phenomena, and ask why is it so important, and what are the kind of consequences and implications of the diffusion of AI for economic growth, for firm strategy, etc. And then there is the other side, which is where you're coming from, Jorge, and also your own skills and capabilities, which are much, much stronger than mine, on implementing machine learning and AI algorithms as a method. So this is done, so whether, this can be a source of competitive advantage is really an important question. So I think Rob's approach and others in kind of thinking about this as a phenomena that we want to understand because it's an important phenomena is potentially more privately rewarding. Thinking about AI as a competitive advantage in strategy as simply from a tool perspective, I'm not sure. I think there are top world-leading econometricians that are using AI, implementing, kind of trying to integrate AI into identification methods and econometric techniques. And this is not a game I personally want to compete in. I want to be a consumer of this market. I don't want to be a competitor. So the question is, how do I, as a scholar, how me specifically uses it, and how do I see me deriving value from it? So the way I've decided to do this is to lead with a question and kind of just define what I do by the importance of the question I'm trying to solve. And then to the extent that I need non-traditional econometric techniques to answer some of those questions, this is essentially an appendix. It's a long appendix with lots of kind of...
of course not.
But the papers I write will never be solved in this methodology. And this is kind of what I'm trying to... and the last thing I would say is, when you think about validation, once you start playing this game of validation, you're likely to lose if the only thing you're doing is trying to validate based on techniques from computer science, etc. In my view, the best validation is using theory that we know better, that is our competitive advantage, in order to essentially make arguments that what we have makes sense, and essentially make arguments for why we need more complicated measures that we traditionally have. So this is kind of how I see this area of research. Thanks.
I think that's great, and it also connects really well to what Rob started, which is like the value of understanding the context really, really deeply, and it really, I mean, one thing I take away from that is that the value of theory with AI turns out to be kind of higher to make it valuable in our field rather than doing away with theory, which is really interesting. So we have a hand up by Anne-Catherine Aiki, please.
Thank you very much. I'm Anne-Catherine. I'm a PhD student, a first-year PhD student at the University of Münster in Germany. First of all, before I ask my question, I would like to thank everybody of the panelists for their very inspiring and helpful presentations. There was much to learn for me. I have a question to Sharon regarding the idea that texts might share similar ideas, but not use the same words. And I found that very, very interesting, also logic, but I mean, we sometimes use just basic cousin similarity, so it's difficult to detect these ideas. And you talked about similarity dictionaries. So how would you recommend to build these dictionaries if we do not rely on patterned texts? So there are a lot of texts to use, and I would just get to know how to build these synonym dictionaries. Thank you.
So, and thanks for the question. So let me just start with a disclaimer. I think that as strategy or economic scholars, you need to make sure that your audience realizes that this is an important problem to solve. This is the first thing I would say. The fact I said that this is a problem that we address doesn't mean that there is an audience for that. And in fact, nobody cares about this problem in the space of patents, at least based on what I've seen in the literature. And when I talk about it, yes, but nobody's kind of taking it seriously. So I would not encourage you to go and solve this problem just because the problem exists. Now, specifically in industry, as well as potentially other research fields, this kind of the question of how do you measure the relatedness of two different words, how do you think about the content they represent, even when the words are different, is a first order problem. And different people have been working on it in different ways. And some fields in strategy do take it very seriously. Bennett Zellner has some work on this in the context of, in other contexts. But what I would say, people typically think about Wikipedia pages, and you have the Word2Vec, different version of that that Google has, which essentially makes the argument that two words are more similar to each other if they tend to appear more frequently in close proximity in documents, in the same sentence, etc. So what these guys did was to crawl Wikipedia pages and use those similar and kind of develop the similarity scores based on whether they appear in the same sentence, same document relative to other documents, etc. So Word2Vec is where I would look. And this is something that is generally applicable to lots of fields, not only to innovation.
Great, thank you very much.
That is great. Do we have any other questions? I think we have 2 minutes. The organizer said we could stay a couple more minutes more, but not too much. But we only have 2 more minutes. Is there any other question from the audience? We have a hand up by Justine Lamrani.
Yeah. Hi. I'm a third year from Erasmus University in strategy and entrepreneurship. And I was just looking at the potential of machine learning to actually make predictions based on large data sets. But I don't see how that could be translated to a research question, because a research question usually have a very defined IV and DV. But if I were to use, for example, some random forest model to make a prediction on how a stock price would go up using a bunch of variables, then even if I have a good predictive model, I'm not sure how that could translate then to a research paper. So my question is then, am I seeing this wrong or from the wrong angle?
I think you can make lots of money, right? If you can do that.
Could I ask any other panelists? Aija, I don't know if you have any thoughts since you had these kind of more causal paper.
Yeah,
anybody else?
I can jump in here. I mean, I'm really not a super sophisticated, like I said in my presentation, sophisticated machine learning methods developer at all. So I kind of tend to go like Rob said, with the question first. I think it was Rob. Question first and kind of the conceptual model first, and then see where text-based variables sort of fit into that. And so I think for us, within our research, we really want to understand the causal model and causal logic behind the result. And I don't see any immediate need for doing sort of pattern description that predicts something valuable, but where we don't really understand the causal mechanisms as well. And so I'm just kind of retrofitting our own old frameworks with pieces from the ML method frontier that's moving really rapidly, and we can benefit from that. So I also see myself as just a consumer of established techniques. So I don't want to be creating techniques, and I don't want to work in an area where the techniques are uncertain and I can't interpret them, or I can't tell the story of how the result came about. So that's just I just don't see myself as going into that, but I completely see how they're valuable in the industry. So, if you can explain something, even if you don't know why, that can be super valuable. So, and I know that, I mean, Sharon talked about kind of the economics literature that's evolving also in kind of the methods literature in econometrics, where people are trying to grapple with that. So causal explanations within ML frameworks. And that's a frontier that's worth following, but I'm not there myself.
And Raj has his hand up.
Yeah, so I can quickly add to what I just said. So I think the one opportunity that we have is to write a paper where we identify a pattern And then we use either abductive explanations to sort of justify it, or go to a second paper where we can causally test it. So, there's a whole sort of like type of paper that is being written, which is called the red state paper, which I'm really excited about. And there's a very nice AMR by Tim Simcoe and Andy King on abductive explanations in strategy research. So I encourage you to read that. I find that kind of paper very, very refreshing, because you look at a phenomena, you say, what is a cool pattern that we can observe in this phenomena? And then you either then go to an experiment RCT to sort of causally validate it, or you generate some abductive explanations for that pattern. And then other people can write a paper that causally validates it. So I think there's definitely a value in predicting and finding patterns.
Sharon and Rob, whoever wants to go first.
So I would just say one thing. There is a great paper by, I forgot the authors, in Science that tried to use machine learning to predict which companies are going to be successful, which start based on initial conditions. Maybe Jorge, you can talk about that paper. By the way, as a great example of how you can use machine learning to answer a really important question without a clear theory and still have a lot of impact.
Yeah, so the idea of that paper is we all know there's a lot of startups, and we all know there's better and worse startups. It's so obvious to everybody that that's true, yet how to do it is very unclear. And so we wrote this paper that shows it's pretty intuitive that if you had a few founding characteristics, you could predict a lot of the variants of which ones are going to succeed and which ones won't. And that actually, and you wouldn't be able to predict any one startup, but the overall variance across geography, et cetera, was actually, part of the insight. And we've, myself and my co-author Scott Stern, we've wrote a series of papers around that. Rob, did you have a thing to add or not? Or
no, I think it would just echo everything that we just heard. Fantastic panel, Jorge. Thank you and Olenka for putting it together.
We're 4 minutes above time. So I just want to thank everybody that came here. I know it's Sunday at 10 a.m. online. And the one thing we all agreed when we were the 10 minutes before starting the session was that our kids are running around somewhere and it's Sunday morning. So I'm sure that's the case for a lot of you. And so thank you for coming. I really want to thank our panelists. They're sort of my personal heroes, and it's really excited to see their presentations and hear all their thoughts on this topic. And thank you everybody that engaged in the conversation. And other than that, enjoy the rest of SMS, and I hope we get to meet in person next year.
Thank you, Jorge.
Thank you.
Thank you.